Hi, welcome back to Math 111. I want to work this example with you. Find the coordinates of all points on the line y equals x that are 7 units from the point 5, 3. So let's take a quick look at what we've got here. We've got a line that is the line y equals x. Now this could be any line. In this case it is the line y equals x. And I've got a point 5, 3. And what I'm asked for is to find all the points such that if I draw that line there of unit of length 7, so this distance from this point to that line is 7, I need to find that point. Now, I can do the same thing on this other side. This distance is 7, and there's a point there. So we want to find those. Well, the fact that I use the word distance tells you that this is a distance formula problem. So let's write d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. In this case, we know that x2 will equal 5. In other words, I'm going to let x2 and y2 be my given points. And so we're just going to call x1 x, and we're going to call y1 x. Now, so I'm saying that this is the point x1, y1. And it could be either one of these. We're actually going to find both of these. They're different numbers, but we'll find them both. But here's the thing. For every point along this line, we know that the x and y coordinates are the same. So y1 will equal x1. Or if I say x1 is x, then that means that y1 is also x, because y equals x along that line. Okay, so let's take this step by step through my distance formula. So my distance is 7, and that's going to be equal to the square root of 5 minus, we're just going to call it x squared, plus 3 minus y, but y is equal to x squared. Okay, so now I need to solve this to find x. So what I can do is I can square both sides, and that gives me 49 is equal to 5 minus x squared plus 3 minus x squared. So 49 is equal to 25 minus 10x plus x squared plus 3 minus 6x plus x squared. Now this is a quadratic equation, so we want to set it equal to 0. So I'm going to gather everything onto the right-hand side. So coming up with 0 is equal to x squared plus x squared is 2x squared. Negative 10x minus 6x is minus 16x. Whoops, I goofed up here. This 3 should be 3 squared, which is 9. And 40, so 25 plus 9 is 34, minus 49 is negative 15. So this is a quadratic equation that probably does not factor. So how do we solve quadratic equations that do not factor? Well, we set them equal to 0, and we use the quadratic formula. So the quadratic formula, remember, is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And this applies when I've got ax squared plus bx plus c equals 0. So in this case, a is 2, b is negative 16, and c is negative 15. So x is going to be 16 plus or minus the square root of 16 squared minus 4 times 2 times negative 15 all over 2 times 2. Okay, let's do a little work. I want to find the value that is under my radical, so that's 16 squared minus 4 times 2 times negative 15. That's 376. I want to see if that will simplify, so let's try dividing by 4. And let's try that again. That doesn't work. Okay. So why did I want to do that? Well, because now what I have is 16 plus or minus the square root of 376, but that is 4 times 94 all over 4. I can pull out that square root of 4 to make it a 2 on the outside, so we'll take that square root because I can. Now we'll distribute the 4, and I've got x equals 4 plus or minus 1/2 the square root of 94. And those are the x-coordinates of those 2 points. So my answers here, the coordinates of those 2 points I'm looking for, would be 4 plus 1/2 square root 94. And remember that y is equal to x. So that point will have the same xy coordinate. That's one point, that's the positive x point, the upper one on my graph, and then the negative one would be 4 minus 1/2 the square root of 94, comma 4 minus 1/2 the square root of 94. And this is how we would solve this problem regardless of the point that or the line that we had. So even if I had a different line, the only difference would be right here, where instead of y equals x, y would equal something else, 3x plus 5, for example, if our line were 3x plus 5. Okay, I hope this has been helpful. This was a distance formula application with a quadratic that did not factor, so we used the quadratic formula. See you soon.